Okay. Well, my name is Jessica. We're from the U of A, and we're part of Science Fundamentals. I'm in my second year of honors in biochem.
My name is Ramesh. I'm so excited to be here with you guys. I'm also from the U of A. I am in my third year of psychology, and we're here today to present to you about coding.
Beauty.
Okay, so some quick fundamentals of coding and what we will be talking about in this presentation is what exactly is coding, what are some basic concepts that you would need to know, and what is coding languages.
So first, we're going to start off with what is coding. So coding is basically step-by-step instructions given to computers or like robots or like phones that help them carry out specific tasks. So they help the device do a wide variety of things, ranging from allowing you to play games, go on the internet, make phone calls. Yeah.
Yeah, pretty much anything. I love this activity. I'm not sure if your teachers provided you with the sheet that requires this activity, but if she didn't, we can just go on with the project or with the activity, the game, if you want to call it, and we'll get started. So there's this girl named Faith, and she's going on a trip to a campground. She goes on a walk, but she doesn't exactly keep track of where she's going. Now she's lost and needs to find a way back to her camping site. So in this picture, you can move in four directions. You can move Faith in the forwards, left, right, or backwards direction. So using a combination of these four movements, help her get back to her campsite using the least amount of steps possible. And count the amount of steps you're taking. Also, you can only move on the red lines. Yeah, so we'll give you guys about 5 minutes to finish this and write down in the chat how many steps you guys were able to come up with. Alrighty. I think that should be enough time. If you guys have any comments, just put it in the comments and let us know how many steps you are able to get. Okay, and Jessica can show you guys the answer. So in this case, the least amount of steps that you can take is, I believe, 10 steps. What was the purpose of this activity? The purpose of this is to show you that the least amount of steps gives you the end result. It's pretty much like a simple step-by-step instruction. These instructions are sequential, and it allows programmers to logically and coherently organize information so that the viewer can read it as easy as possible.
Okay. So who codes? So someone that codes is called a programmer, and they basically just work with computers and electronics, and they give the computer/electronics the information required for them to do their tasks. So yeah.
All right, let's jump into some fundamental concepts that you all should be somewhat familiar with by the end of this presentation. So one of the fundamental concepts of coding is loops. Loops are whenever a programmer wants to repeat something. So they usually repeat a set number of times from the coder or until a particular condition or end goal is met. So something as simple as calculations or questions can be looped very easily. What this does is the loop helps the user reduce the number of codes, just like we did in the last activity. We reduce the number of steps in order to fulfill a goal. It makes the code much easier to read, and this is what allows the computers to run really fast instead of making it slow. So think of an example of brushing your teeth. You brush it every day, every night, and hopefully in the mornings too. Or for example, think of when the store owner or a store representative is counting the people that are coming into the store. Every single person that comes in, you add a number. So you're kind of going in a loop.
Okay. And then there's condition statements. So these are specifications that we put on code to limit unwanted information. We can specifically include or exclude something we want in order to gain the information that we need. So we check the condition and decide on the action or outcome depending on the condition. We're going to show this in our second activity here. So in this activity, we have 3 fruits on display: oranges, apples, and bananas. So the condition for this activity is that apples can be next to oranges, but cannot be next to bananas. So based on this condition, which of the following arrangements do you think follows these conditions? We'll give you some time. Again, you guys can type it in the chat, like the numbers you think would work for this condition. And we'll give you like 2-3 minutes. Okay, so I can see all the numbers are put in the chat. So maybe I was a little unclear about my request for this activity. Out of like, there's number 1 is the first picture, number 2 is the second picture, number 3 is the third picture, number 4 is the last picture. So which of these pictures would follow the condition? So the correct answer would be 1 and 2, as they're the only two in which apples are next to oranges, but are not next to bananas. So in this case, this apple's next to this orange, but it's not next to the banana, and this apple's next to this orange, but it's not next to this banana. In these bottom ones, the apple is next to a banana, so therefore these two do not match the condition at the top. Okay. Okay, so this is similar to the last activity, but we're going backwards in this case. So we're giving you the two pictures, like the two correct organizations, and we're asking for a way to describe, like, what condition would you put into the computer in order to get these two outcomes.
Yes,
Again, we'll give you, oh, sorry.
You just have to like make a set of rules, right? Yeah.
So like an example, bananas must be next to oranges. That would be something that you have to include in here, because all the bananas here are next to oranges. Stuff like that. Yeah. Again, we'll give you like a couple minutes just to think about it. Okay, so these are the possible conditions for this organization. So apples can be next to cherries, bananas next to oranges, bananas must be next to cherries, or you could say cherries must be next to apples and bananas, and oranges must be at an end. So either one of those two would work great as a possible answer.
Alrighty, so now we're going to get into decomposition. We're going to look at what are some ways you can solve some really big problems by yourself. So in a way you can do this with coding. It's very similar to real life. I mean, we can have analogies like if I had a huge problem to solve, let's say a math problem, I would break it up into very, very small pieces and I would solve them one by one. So a programmer will often face many, many complex problems. A useful technique they can use is called decomposition. So when you decompose a problem, you pretty much divide the problem into much, much simpler parts, and it makes it easier to manage, and it allows the programmers to tackle each part individually instead of tackling the whole problem all at once. So think of it when you're trying to fix your computer on your own, and your computer is testing, like you have to know how the heck are you going to fix your computer. So you have to test a bunch of different parts of the computer, maybe even break down the computer, open it up. That's what they would do. They would decompose this problem and fix simpler parts instead of the whole.
Okay, so the last thing we're going to talk about is coding languages. So coding language is the language that we use to communicate with computers, because computers don't really read English, so we have to convert our English into a language that they understand. So think of coding languages as like different brands of phones. There's like Apple and Samsung, and though these phones have different features and software, they also serve more or less the same purpose: to make phone calls, go on the internet, play games. So different coding languages can program the same thing, but there are different ways of describing it. So here's some common ones. There's MATLAB, Python, Java, and like there's many others, and like some of them are more popular than others. But yeah. Do you guys have any questions? You guys can just put them in the chat. If not, Ramesh just put a link in the chat. That's just so where you can go to like give coding a try. It's super fun. I made a purple cat. I can show you that. It's super cute. Yeah. And that's it from us. So if you guys have any questions, just put it in the chat. Other than that,
someone asked if there will be more workshops from us. So you can learn more about coding languages. Like the website we gave are for people to give it a try, see what the idea of coding is. You can learn more about it. Maybe I can ask some of my colleagues, the people in the exec team, to give me more resources, and then I'll provide them to you. I can send you the full presentation as well, the full workshop. Just because this was a 20-minute one, we made it much smaller, and we took out a lot of important parts to decrease it from 1 hour to 20 minutes. So I can definitely send in more. With coding, we don't have any more workshops, but we do have a lot of different workshops in the sciences field, like let's say acids and bases or psychology. I know there's a bunch of different workshops we do offer. I will send you an email, and I think you can contact our main exec team to ask for more workshops that we can give to you.
for sure. And this is my purple cat. She's cute. She says hello and that she loves coding. So yeah.
Yeah, so you just pretty much like drag the actions, and it's really fun. I tried it and I was just like fiddling with it for a good half an hour. But it's pretty cool. You can make him do flips, you can make him change its costume. Yeah, it's really fun.
Okay.
But yeah, thank you guys for your time. Are there any other questions?
Okay. Oh, great. Beauty. Thank you guys for having us. Hopefully we'll get to see you again.
Yeah. Thank you. Bye, guys.
Bye.